All right, welcome back. For people that are watching this on video, we are doing section 2.2. This is on the derivative function. The derivative of the function f of x with respect to the variable x is the function f prime of x, sometimes just abbreviated f prime. Because mathematicians are notoriously lazy butts. Some of us may be very physically active, but we're like lazy as fuck when it comes to mathematics. Whose value at x is f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x over h. Again, provided that the limit exists. There are other ways you will see this. This was, I believe it was a Newton thing, Isaac Newton. But someone else invented calculus at the same time in a different part of the world and they didn't have fucking internet. But Leibniz did calculus at the same time. I think that's how you spell his name. And his f prime of x is dy dx. This is the same thing as saying d dx of y. Or d dx of f of x. And you might see y prime going back to Leibniz notation or Newton's notation. Those are the most common ways you'll see derivative listed. You might also see in rare textbooks, capital D with a little x subscript of f of x. That shows up too. This one tends to be when you're doing multiple variables. And it allows you to say, like, this is no longer an f of x, but it might be f of x, y, z. And you'll say which variable you're treating it with respect to. So the with respect to part in each of these. It's the letter inside there, or it's the letter that shows up on bottom. The only one that doesn't show it is y prime. And y prime is generally, this is the worst way of doing it, but like it's the shortest way of doing it. And by the time we use it a lot, most people are comfortable with y is f of x, they're just interchangeable. Let's do an example. If f of x equals x squared plus 2x. Find f prime of x. We're going back to that definition thing for a little bit. I think in 2.3 we'll start introducing shorter forms of this. X plus h, we're just sticking in x plus h wherever we see x. So I've got x plus h squared plus 2x plus h. And I have minus x squared plus 2x. And unfortunately, my dumbass didn't put the 1 over h out front, so I'm gonna leave it in the denominator here. It really makes it like you can, it looks cleaner with the 1 over h out front. You'll find you get tired, this looks like it takes up more space on your page, it just does. So on the next line, I'll move that h out front. This is x squared plus 2hx plus h squared plus 2x plus 2h. Then minus x squared minus 2x. Oh, I actually have Leibniz written down. I have the I and the E backwards here. Leibniz, I think is what it is. Well, these should cancel, negative x squared is there, and negative 2x or positive 2x is there. They'll cancel those. We have the limit as h goes to 0. 1 over h times 2hx plus h squared plus 2h. We move the h in. 2x plus h plus 2. And we get down to our final answer, we can evaluate at h equals 0, we can plug it in now. And we get 2x plus 2. That is the derivative function of f of x. I promise you this gets shorter and quicker next section. But you really gotta know where it comes from, because sometimes we gotta go back to the basics here when we don't know how to do something. You all right? Figure it out. Anyone need this longer? All right, onward we go. Times. Make a mess up here. Alright, let's do another example. Find f prime of x. If f of x equals 2 minus x over x plus 1. So we got f prime of x. It's the limit as h goes to 0. I'll put the 1 over h out front right now. And in the first set, everywhere we see x, we're going to replace with x plus h. 2 minus x plus h over x plus h plus 1 minus 2 minus x over x plus 1. And you know what we have to do here. And I know you don't want to do it. But we don't really have another path forward. We gotta get a common denominator. That's how we deal with fractions. So we'll multiply this one. Is gonna get hit with the other denominator. And this one will get hit with that denominator. So f prime of x. Limit as h goes to 0, 1 over h. We're gonna have, well, I'll distribute that minus real quick right there. Times x plus 1. And then we have the 2 minus, we're doing minus, and then we have 2 minus x. And that's getting multiplied by the x plus h plus 1. And now we have this big old giant clusterfuck of x plus 1 and x plus h plus 1. Yep, well, you get to multiply it all out. So I have 2x plus 2 minus x squared minus x minus hx minus h. That's the left one. I'm gonna put this in parentheses, that way I'm not dealing with this minus sign right now. I'm just gonna do the product and do the minus afterwards. I've got 2x plus 2. Wait, what the fuck am I doing? 2x plus 2h plus 2, there we go. Minus x squared minus xh minus x. And we still have the x plus 1, x plus h plus 1 on bottom.
Distributing that out.
We're gonna distribute it out. I just didn't want to make sure I didn't fuck up the signs. Cause trying to do the signs, when we got 6 terms here. All it takes is fucking up the minus sign on one of them and the answer is wrong. So I deliberately left it off till afterwards so that I would minimize my chances of mistake. And then I'll do that, just distributing the minus there, minus 2x, minus 2h. Minus 2 plus x squared plus xh plus x. What cancels? I've got a 2x here and a negative 2x here. I've got a 2 here and a negative 2 there. The x squareds cancel too, right? Negative x squared and plus x squared.
X's.
The x's cancel. Hx and xh are the same thing, right? They're just multiplied. You can change the order. 2 times 3 is the same as 3 times 2. Those cancel.
And then you can combine the H's.
Yep, it looks like we just end up with. Don't forget our 1 over h up front. It looks like we just got negative 3h on top. And of course, these h's cancel each other out. So if I were to write it with everything cleaned up, but before I evaluate h as 0. I have negative 3 over x plus 1 times x plus h plus 1. So I just get negative 3 over x plus 1 squared.
That's because the H is just 0, right?
Yeah. We're doing our limit as h goes to 0, and so after I do h to 0, I can dump the limit because I've activated it.
Well, my question was, where the fuck did the 2 minus x over x plus 1 came from? That's just like x. So
Yeah.
it finally clicked.
For those of you that like video games, you can treat that limit thing as like a med kit. It's sitting there, it's sitting in your inventory, or a potion if you're playing like a different type of game. Sitting there until you use it, then it's fucking gone, but it fucking changes some shit. That's a very. I've never even tried to explain that in terms of video games, it just popped in my head, I don't know if that's helpful.
You can only use it once.
Well, if you use a medicine kit, the medicine's used up. In some games, like it has more than one charge, but. This you use it once. And once you use it, it's gone. Alright, you ready for another? We got time for one more and then we'll end it before we won't finish 2.2 today. What?
Before it gets worse.
No, before it gets easier.
Really?
This is the worst part.
Oh.
I told you, we're good leading to where we get rid of limits for the most part. But we gotta understand how all this shit works.
Yeah, because writing LIM, H equals 0 every time is starting to piss me off, John.
I bet it is. You guys ready?
Make me right off my phone.
I know.
That's why
You gotta learn it, you gotta learn the ropes.
that's why I'm not.
You don't start running before you start crawling. You don't start doing exponents before you learn multiplication. Alright, so. F prime of x if f of x. Is square root x. That can't be that hard, square root x, that's not complicated.
It sounded like a trick, yeah.
Of course it's a trick. I'll do my 1/h. We got x plus h minus square root of x. If I plug in h equals 0, I have 0/0. So. How did we deal with square roots when we were doing limits last chapter?
Redo this fraction.
Multiply by the conjugate. Yeah, let's do that. And remember, the reason why we like doing that is this is a minus b times a plus b. The top is a squared minus b squared, which is just gonna be x plus h minus x. And the bottom, we don't even have any multiplication, it's just the new denominator. Because we had a 1 on bottom before. Actually, this is a lot shorter than that, maybe we will cover a little bit more today. But it's just like more descriptions of shit. So like the X is on top, cancel, right? I just have h over square root of x plus h. Plus square root of x. And now I can cancel out the h's on top and bottom. We use our med pack, hit the h with 0. We have square root of x plus square root of x on bottom is 2 square roots of x. And that's our f prime of x. As a reminder, if it hasn't been that long, just like half hour, but what are we doing this for? It helps us find the slope of a tangent line. So let's find the tangent line. To y equals square root of x at x equals 9. M tangent is that derivative, it's f prime of x evaluated at 9, so f prime of 9. Which is 1/2 times the square root of 9. Which is 1/6. And we're doing y minus y naught equals m times x minus x naught. What is y naught? If this is like our x naught. Y naught's gonna be square root of 9, which is 3. We're looking at the 0.93. So y minus 3 equals 1/6 x minus 9. Three equals 1/6 x minus.
Where did the 3 come from? Oh,
Square root of 9. It's 3 halves. So if I were to clean this up, just make it a function of y, we get 1/6 x plus 3 halves. We haven't done yet? So like all of this required that the limit exists, right? Every time I said the derivative there, it's provided the limit exists. So that's a pretty important concept. So all of this was all dependent on if the limit exists. So if the limit does exist. At x naught. We say that. F of x is. Differentiable. At x naught. So like. F prime of x naught. Equals limit as h goes to 0. Of f of x naught plus h minus f of x naught. Over h exists. That's just at a single point. If we wanna look at like over a region of numbers. Like from A to B. If f is differentiable. For every point in AB. Then we say f of x is differentiable there. Like, seems like obvious. On AB. So where functions are not differentiable. I.e., we can't do the derivative. At corners or cusps. Like it comes to a point. Vertical tangents. At discontinuities, of course, if there's no point there. It's not continuous there. And this one a little hard to, like, it happens, but if the graph oscillates wildly there. Wild oscillations. Like. Fucking just rapid, fucking just back and forth. The river may not exist there. I'll just show you a quick one of an example of the first one. This is like f of x equals the absolute value of x. And that's defined to be x if x is greater than or equal to 0. And negative x if x is less than 0. So like. At x equals 0. For this limit to exist. For f prime of x. Equals the limit as h goes to 0. Of f of x exists. It has to be from both sides. Remember that? So I've got f prime of 0. Equals the limit as h goes to 0. F of 0 plus h. Minus f of 0 over h. Absolute value of h. Minus 0 over h. Limit as h goes to 0 from the left. When 0 is left, and when we're coming from the left, absolute value equals negative. So we're gonna replace the absolute value of h with negative h on top. The bottom is still h, and this is -1. If we look at it from the right. We can just leave positive h. Which equals 1. And these two don't exist. So the limit doesn't exist. And it's not differentiable. At x equals 0. There's no derivative there. And it's because it makes a corner there. That's where x equals 0. It's a corner. All right, that's it for that. We'll do a little bit more in this section on Tuesday. I'll go scan this, upload this. As a reminder.